Now just a few integrals or find the antiderivative. So with this one, we could use u substitution. So let u equal the bottom part, x cubed plus 3. The derivative of that is 3x squared times dx. So in order for this u substitution to work, you have to have x squared times dx. We have x squared times dx. So just get rid of this 3, multiply both sides by 1/3. And then it's ready for the u substitution. So this 1/3, I prefer to just factor that out. And then the numerator would be just du. And the denominator, well, that's just u. Then find the antiderivative. Since this is 1 over u, the antiderivative is natural log. Don't forget about the plus c. And finally, replace the u with the x cubed plus 3. So the final answer is 1/3 the natural log of x cubed plus 3, and then plus constant c. Then what about for part B? So if you do u substitution, the u would equal the bottom part. The derivative of that is not equal to the top part. So what we should do is split this into two integrals. So rewrite it as two things that have 3x minus 5 as their common denominator. And then separate the numerator into 2x for this one plus 1 for this one. So if you do u substitution, the u will equal the 3x minus 5 for the bottom part. The derivative of that is just going to be 3 dx. Now notice that neither of them have 3 in the numerator, so multiply both sides by 1/3. And then that's what dx gets replaced with. So for this one, it's all ready for the u substitution. We've got the dx, we've got the u equals the bottom part, we would factor out a 1/3, so that one's ready. This one though, it has this extra x, so we have to find out what x equals. Well, if you go right here and do a little bit of algebra, you could add 5, and then you could divide by 3. So u plus 5 divided by 3, that is what x equals. So this one's going to require a little more work because of that. So the first one would look like 2 times x, and then x gets replaced with u plus 5 over 3. And then this part right here gets replaced with u. And then the dx, because the dx of course applies to both of these rational functions, the dx gets replaced with 1/3 times du. And I'll just put the 1/3 right here. All right, then on to the second one. So then this one is going to be, now this one is going to have different constants than this one, so I'm going to write this one as its own separate integral. So this is going to be 1 over u, and then the dx gets replaced with 1/3 du. So 1/3 du. And then, let's see, this is a 2/3, which I could factor out. And then I would have a 2/3 times a 1/3, so that's 2/9. And then what's left is u plus 5 over u. And then just like I broke this one up into two fractions, I'm going to do the same thing here. So this one is going to be 2/9. And then you could rewrite this as u over u plus 5 over u. And then this guy over here is going to be the natural log of u plus c. And then we're almost done with it. So this is a 1, so the antiderivative for 1 will be u. So it's got the 2/9, and then the antiderivative will be u. And this one is like 1 over u, so the antiderivative is natural log. And what remains? So there would be 2/9 u plus, if you distribute this, that's going to be 10/9 natural log of u plus, and then I'm going to change this one to ninths. So multiply the top and the bottom by 3. This is going to be 3/9. And then so in total, this is going to be 13/9 natural log of u, and now we can replace the u with 3x minus 5. And this part will be 2/9, and replace the u with 3x minus 5. And then there's a plus sign in between. That one was pretty fun. I like that. All right, then for part C. So part C is integrate cosine squared and for this we need a trig identity. It's 1 plus cosine of 2x divided by 2. And then I'll factor out the 1/2, and it leaves 1 plus cosine of 2x, and that's what we need to integrate. Well, the antiderivative of 1, that's just going to be x. The antiderivative of cosine, that's going to be sine of 2x. And then because of the chain rule, you have to divide by 2. And then I would go ahead and distribute the 1/2. So it's going to be x over 2 plus sine of 2x. And when you distribute the half, it's going to be over 4. And then plus c, and that one's finished.